Okay, so continuing on, where most of the problems in this section are essentially wanting you to graph the rational function. So there are a few things that you need to do in order to graph it. These are a little bit more complex than, especially linear functions and quadratics, but maybe even more so than higher degree polynomials too. There's at least more moving pieces here. So here are some things to make sure that you do. Um, Always want to factor the numerator and the denominator first. Then we're going to find the x and y intercepts. Then we're going to find the asymptotes. And then we can usually, and these are always going to be multiple choice on the homework. I don't think WebAssign has a way to graph, plotting points and get a rational function that way. So these are all multiple choice. So that makes it a little bit easier, but it is possible that you have to do more than these 4 steps, and you have to do another trick, which we'll talk about because we're just going to do all these by hand. But I think doing these by hand and then getting to the homework and having multiple choice will make things a lot easier once you get to the multiple choice ones. So let's look at this one. So first things first, we want to factor the numerator and the denominator. And so let's see, I think this one, we have 2x and x, and then we need plus 7. So I think this would be a plus 4 and a minus 1. That looks like it would work. And then this one on the bottom, we'll have an x plus 2 and an x minus 1. And that looks like that'll work as well. So next thing you want to do is make sure that nothing factors and nothing does. That's usually pretty easy to tell. So now what we're going to do is we are going to find the x-intercept. We will find the y-intercept. We will find the vertical asymptote, and we will find the horizontal asymptote. Now, I kind of do these, whenever I work a problem that's multiple steps like this, I usually try to lay it out in the same way on my paper every time, just so that you get to, at least the way I do it, the way I think. I kind of get used to looking for things in the same spots. So, in other words, if you kind of put the x-intercept and y-intercept here, and all of a sudden you switch them on the next problem, you got to really think which one is which. So I think it just makes it easier. Now for the x-intercept, we're just setting this equal to 0. And really, we're not worried about where the denominator is 0. We're worried about where the numerator is 0 for the x-intercept. And so we're setting both of these equal to 0. We get x equals 1/2, and we get x equals -4. And those are our two x-intercepts. For the y-intercept, that's pretty easy. We really just need to look up here, and we're plugging in zeros for the x. So those are all canceling out, and we just left with a -4 over -2, which is 2. Now, you might want to put these as ordered pairs just so that you're not confused on which is the intercept and which is the asymptote. So here are our ordered pairs, and you can go ahead and plot those if you like. You can go ahead and do these, and I mean, however you want to do it. We'll just put a few tick marks. There is our x-intercept at 1/2, and then here's our x-intercept at -4. Now for the vertical asymptote, we set the denominator equal to 0, and we get x equals -2, and we get x equals 1. So we can go ahead and put dotted vertical lines here. We know the graph is not going to cross there. And it looks like that. And in the horizontal, we're going to compare the degree. So we have degree 2 here, we have degree 2 here, so the degrees are the same. So it's just the ratio of the coefficients. So that is y equals 2. And so let's go ahead and draw that. All right, so now remember, the graph does not cross the vertical asymptotes. It may or may not cross the horizontal. So just kind of be open to that. So the way we can decide, is it coming like this? Is it coming like that? Is it coming up like that and then coming back down? Obviously it goes through this, but let's kind of see what is going on here. So we know this is at -2, so let's look just on the left side of that. So let's see what happens when x is -2.1. So we're just going to pick a number very close to that, but on the left side. So now the easy way to do this, you could plug it in. You could plug in -2.1, see if it's positive or negative. That's really all we're worried about. Is it positive or negative? But you can also, we have the factored forms here. If you plug in -2.1 into this factor, that is going to be a negative. If you plug it into this one, -2.1 plus 4, that is a positive number. -2.1 plus 2 is a negative number. And then -2.1 minus 1 is also a negative number. So now we have a negative number on top. When you multiply those, a negative factor times a positive factor, that gives negative. Negative factor times negative factor gives a negative. So that gives a negative, sorry, negative over negative times a negative gives positive. So a negative up here, positive down here, that is going to be a negative. So this one is less than 0. So we basically know this one looks like that. And I meant to go through that, but that's fine. All right, so now look at the other side of x equals -2, and let's say -1.9. And we'll do kind of the same thing. You could either plug this in up here, just use your calculator, or you can do this little trick and see, because we're really just worried about if it's positive or negative. So 2 times -1.9 minus 1, that's going to be a negative. -1.9 plus 4, that's going to be a positive. -1.9 plus 2 is going to be positive, and then -1.9 minus 1 is going to be negative. So here we have a negative over a negative. That's going to be a positive. And so we know it's going to come down like this. We also know the y-intercept is 2, so it's going to hit right there. And so now we need to see what happens on the x-intercept the asymptote x equals 1. So let's go a little bit on the left side of 1. Let's do 0.9. Plug in 0.9 for the x's. So 2 times 0.9, that's 1.8 minus 1. So that'll give us a positive. 0.9 plus 4, positive. And 0.9 plus 2, that's positive. And then 0.9 minus 1, that's a negative. So this one is negative. And so it's going to come all the way down. And you can't not really assume anything. These could really go in any direction. So this one, I mean, it's pretty safe to say that one's not going to go up just based on this and this asymptote up here. But I mean, it's not impossible, I guess. This one, I mean, you could have it where it comes up like this and then comes back down, or you could have it to where it kind of comes like this and then sharply comes back up. There's really no guarantee for anything. So don't try to guess. Just work these out, and you'll get the graph right. All right, so we plug in 1.1, and that gives us a positive right here, positive there, positive there, and positive there. So those are all positive. That's going to be positive, of course. And so it's going to come down something like that, probably. I mean, it could come down and back up, but we're not worried about that because these are, again, multiple choice. There won't be two that do everything except the one little thing that is hard to figure out. So that's basically what the graph looks like. And so now let's get the domain and range. And so here, just look at the graph. I mean, let's not go with anything else. Wherever the vertical asymptotes are, those points will not be in the domain. So the domain is usually pretty straightforward. And you really don't need the graph for that. Once you find the asymptotes, the domain will be everywhere else. So we have negative infinity to -2, parentheses, union, -2 to 1, union 1 to infinity. So we're just taking out the two vertical asymptotes there. Now the range, you got to be careful because you cannot just take out where that vertical asymptote is, because it is possible, and it does in this case cross the vertical asymptote. And we can see from this middle section here that the range is going to be all real numbers. So the range may or may not be all real numbers on these. The domain never will be if we're set up with an irrational function. So domain's never all real numbers. Range could really be about anything. It could be, you could have it all on, below the x-axis or above the x-axis or whatever it is. The range could be almost anything. Okay, so I think we'll stop with this one and come back and do some more on the next one.